we are trying to understand and construct a seasonal index. We have come to the last column, which is nothing but a percentage of the actual to the constructed average here. It is not the index, it is average, and it is a moving average, and it is evened out a number of times, so that all the extreme values are taken care of, they are eliminated. First we take the quarterly value and average it for a quarter, then we take this and do it for 2 quarters. So, then the actual value as a percentage of the average is taken, and that is the average here we are seeing, that is 114.8 etc., etc. Now, what we will do is we will draw another table from this table. From this column we will create one more table like this. 1999 same years, 1998 etc., same years, and the final this value will start with this quarter wise, quarter 1 89, quarter 2 107.4, same values, from here it will come 107.4 etc. We will again plot it and keep it in this table. Now, the modified mean of this, we take the mean of these values. It is simple, if you want you can calculate, and you get the value 91.25 for quarter 1, 107.70 for quarter 2, and similarly 113.25, 91.90. It is simple, 4 values total divided by 4, these 4 values divided by 4, again we get the mean, Now, total of these 4 indices, it comes to 40410. The total of the 4 indices is coming to 40410. Now, here you may note one point, the total of 4 quarters indices should come to 400, not 404.10. So, but it comes to 404.10, that means something as we average and we plot, the value slightly goes up. So, we have to bring it down to again 100, that is 4 quarters 400. That exercise we will do now. Now, it is I think clear to you. What we have done is I will briefly go back. This somewhat arithmetically very intensive exercise. So, unless you are very clear, this will take you nowhere. Now, we have taken the actual data. This is the data given in the problem itself. The room occupancies of a hotel during the 4 quarters, during particular years, 1998, 98, whatever it is. These are the actual occupancies. Then we take the moving quarterly average. We follow 2 steps. We get the quarterly average here, the moving average. We take the first 4 values, then we leave the first one, take the next 4 values, we arrive at this quarterly average. Then these 2 are added and divided by 2, again one average we will get here. Now, this actual occupancy as a percentage of this average, that will come here. These are the actual percentages. Now, that from this we draw a table, first quarter, second quarter, third quarter, fourth quarter. Then we try to find the mean of each quarter here from the new table. Yes, from the new table we find the mean. It is for each quarter it is 91.7, 91.25, 107 etc. That is the mean for each quarter. Then the total value of the 4 quarters mean, the total indices is 404.10. But as a matter of fact, here what we will do is the modified means, yes, here the modified means, it is not simply this divided by 4. Let me take the calculator. It is not see 89 plus 88.6 plus 93.5 plus 94.5 divided by 4 is 83.9, whereas modified mean for quarter 1 is 91.25. So, it is not simple mean of the 4 values. Please note, this is not the simple mean of these 4 values. Here, if you recollect some of you, as I already told you, working in forex and all that, we will be polling the rates. We call it a poll. We poll the rates to FEDI, we poll the rates to FIMDA. When we poll the rates, FEDI and FIMDA, what they do is, while arriving at the average, they remove the extreme values. They remove the extreme values, highest and lowest they will remove. So that that is evened out. There is no effect of these extreme values. So it will be somewhat a smooth average. Same thing is done here. This is 89, 88, 93, 94.5. The highest and lowest are eliminated here. The highest value and the lowest value. Highest is 94.5 and lowest is 88.6. Let us see what happens. Highest is 94.5 is eliminated. Lowest is 88.6 is eliminated. So 89 plus 93.5 divided by 2 is equal to 91.25. Yes, that is the value that we have arrived at. This 91.25 is the average. After eliminating the highest and the lowest here, we get the average here. So likewise, for all quarters we have done, the 4 averages are obtained and the total index value is 404.10. Right? Now what we have to do is, we have to reduce it to base 10. Now it is 404.10 value. 4 quarters, 4 into 100, it should be 400. So we have to reduce it to base 100. So then we will be able to construct what is called a seasonal index, right? So that is done by this simple 400 by 404.10. Simple. It is 400 divided by 404.10, which is equivalent to 0.98, something like that, 0.9899. Right? Now we have to, from this value, that is modified means 91.25. Originally we have calculated here 91.25. These 4 means. Then we have to account for the change or for the extra 404.10, 4.10 extra is there. So that we have reduced it to base 100. So we have to convert that into that. So that will, when we do it, 91.25 into 0.9899. That simply it comes to that. So it will be less than what we have got. It is 90.3 for quarter 1, 106.6 quarter 2, 112.1 quarter 3 and 91.0 for quarter 4. Now this is ultimately the modified seasonal index. Seasonal indices, now we have to use it now. Now this is the index what we have constructed after averaging out all the quarterly values, after eliminating the extreme values, then after accounting for the increase in the index, quarterly index, all that we arrived at these values. Now seasonal indices are used to find out the seasonal variation, right? Now to actually see what is the value or what is the projection after the incorporation of seasonal index, the original first quarter occupancy is 1861. That is given in the table, I mean in the problem itself. So 1861 divided by 90.3 is the index which is reduced to base 100, 90.3. 90.3, that is divided by 100. That is equal to 2061. For each quarter we will do that. So quarter 2 is 2067, quarter 3 is 2154 and quarter 4 is 2097. So these are the final figures. This is the deseasonalized, we call it deseasonalized index. The seasonal value reflects only the trend, cyclical and irregular components of the time series. Now we can compute the trend line and use of predictions. Now we have computed the deseasonal index. Now it takes a lot of time. So now we have arrived at the deseasonal index. We use this for, projection or what is called forecast. Suppose the resort manager, from the deseasonal trend line, that the deseasonal average occupancy for the fourth quarter next year will be 2121. That is his projection or his prediction, whatever you call it. He predicted an occupancy of 2121. Then to get the correct picture, we must take seasonality into account. Therefore, multiply the deseasonal predicted estimate by the fourth quarter, because it is in the fourth quarter. He is predicting for the fourth quarter. This 2121 he predicted for the fourth quarter. Take the fourth quarter our constructed index, that is 91.0. So, is equal to 2121 into 91.0 divided by 100, that will take you to 1930. There will be an average occupancy of 1930 rooms in the fourth quarter of the next year. See simply against a prediction of a 2121, after constructing all these seasonal index and all that, if you deseasonalize, the occupancy, actual occupancy will be 1930. That is the whole purpose of this exercise, to construct a seasonal index and to separate seasonal index, I mean seasonal variation from the secular trend and arrive at the secular trend. So, this you can very broadly say this is the secular trend. 1930 is the secular trend, it is devoid of that seasonal effect. That is what we are trying to prove in this example.